Hello students, this is the second in a two-part video series about the Unit 6 review packet. I'm going to be going over the last half of the review packet, talking about different points of concurrency in triangles, like centroids, orthocenters, circumcenters, and incenters. If you haven't already done so, please pause the video to try and answer the questions in this packet, and then come back to see if you got them right. Alright, as a quick note, all of these questions talk about coordinate grids, and they will probably not ask you to make incenters on a coordinate grid on the Regents exam. Angle bisectors are very difficult to make on a coordinate grid. You would usually use a construction to make them, so they won't ask you about angle bisectors, they won't ask you about incenters. Anyway, the first one asks you about centroid. If it's looking for a centroid, that means we're looking for the intersection of all three medians, and medians are what happens when you connect a vertex to the midpoint of a base. So I already know all these vertices, they're given to me. All I need to do is connect the vertex to the midpoint of the base that's opposite. So for example, I'm going to connect R to this midpoint, I'm going to connect P to this midpoint. So let's find these midpoints. The midpoint of PQ is in blue here. I use the formula x1 plus x2 divided by 2 and y1 plus y2 divided by 2. That is the pretty standard formula for midpoint that you've been using since Unit 1. 1.5 comma 4 is the midpoint. It's not an exact value for x. That 1.5 is in between 1 and 2, but it's pretty easy to find when you look at the graph. Finding the midpoint of QR is very similar. That would be 0 plus 6, x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. It's at 3 comma 6. That is here. Once I draw these two medians, which is midpoint to vertex, midpoint to vertex, I find an intersection point. Now, as a quick reminder, you know that if you were to draw the third median from Q to side RP, that would also pass through this centroid. It is not necessary for me to draw all three of the medians, however, because once I draw these two medians, they already intersect only at one point, which means I've found my centroid. Again, if I'm looking for the centroid, or if I'm looking for example, later on we're looking for orthocenters or circumcenters, it's not necessary to draw all three of those lines for the triangles. It's only necessary for you to draw two. For question number 7, it asks you to determine the point of intersection of the medians. That's another centroid, and to state its coordinates. Anytime it says state its coordinates, you must write the coordinates down somewhere. You can't just put a point. You must write them down somewhere like this. Finding the midpoint is very straightforward. We've done it before, so I show you these calculations. And then the intersection of the medians, which is what it asked for, otherwise known as the centroid, is at 0, 1. That's here. For question number 8, it asks for the circumcenter. Now, knowing that the circumcenter is the intersection of all the perpendicular bisectors, this is the peanut butter cookies from before, is important for this question. We need to find midpoints because a bisector intersects a side at its midpoint. So I find the midpoint of BC, which is 5, 1. That is 5, 1, which is here. I didn't find the slope, however. I was able to figure out perpendicular from realizing that BC is a vertical line. If BC is vertical, that means that its perpendicular line must be horizontal. We're going to be getting into that a little bit later in a future problem, in problem number 9. So I was able to draw this this perpendicular bisector without any trouble at all. For AC, however, finding the midpoint of AC, I was able to find it using the midpoint formula, but then I found the slope of AC. The reason I found the slope of AC was because once I find the slope, which is -2/1, I use the negative reciprocal slope to turn it into its negative reciprocal, so I find the slope of the perpendicular bisector of that side. So, starting at the point that I found already, the midpoint, I'm using the negative reciprocal slope, which is 1/2, up 1/2, to draw this perpendicular bisector. Once I drew the perpendicular bisector, I found that it intersected the other perpendicular bisector at one point. That means it is the circumcenter, and it is at 1, 1. So I found the coordinates of the circumcenter, good to go. For question number 9, it asks for the coordinates of the orthocenter. Orthocenter is, of course, where all the altitudes meet. So I need to find the slopes of two lines, and I need to find their negative reciprocal slopes in order to make perpendicular lines. For DE, I know that DE is a vertical line, so I'm going to use my trick again. A vertical line's going to be perpendicular to a horizontal line. And it was easy to figure out where to draw that horizontal line because that horizontal line has to meet up with, that's right, the opposite vertex. So from DE, I'm going all the way across the triangle to F. So I start at F, and I make a horizontal line. Next, I found the slope of EF, which is this line here. That slope was negative 1 over 2. I found the negative reciprocal slope, which is positive 2 over 1. And starting at point D, I'm going to go up 2 over 1. Well, I can't go up and over any, but I can go down 2 over 1 to the other way. And drawing that altitude in, I'm able to find the orthocenter, and I state the orthocenter's coordinates. The point of intersection of the perpendicular bisectors, of course you know that's the circumcenter, is found in very similar ways. We know that this is a perpendicular line, because we found the two slopes, the slope of AC and the slope of BC, and then we turn them into their negative reciprocals, respectively. I was able to find the midpoints using the midpoint formula, and starting from the midpoint, I use the negative reciprocal slope. Starting from the midpoint, use negative reciprocal slope. The circumcenter is at 0,6.5, which, as you should remember from before, I know that the circumcenter of a right triangle, this is a right triangle, is going to be located at the midpoint of the hypotenuse, which is a fun thing to know. In this diagram, it wasn't really necessary for us to draw anything. It just asks for the slope of the altitude, and you should know that the altitude is always perpendicular to the base. If the base is AB, that means I find the slope of AB and find its negative reciprocal. Easy peasy. Moving on to the next part, which is about mid-segments. Pause the video, try it out, and then come to see if you got them right. All right, we're looking at a mid-segment, and you know that a mid-segment does three things. It connects the midpoints of sides, it's parallel to its opposite side, and it's half the length of the opposite side. So what's the relationship between DE, the mid-segment, and AC, the base? Well, this segment is going to be half as long as AC. It's also going to be parallel to AC. So DE is parallel to AC, DE is half as long as AC. The perimeter of ABC, which is the larger triangle, is 23. The perimeter of BDE, which is this smaller triangle, is going to be half as large. Half the perimeter would mean 11.5. And for the area of ABC being 14, we're looking for the area of BDE, the smaller triangle. The area of BDE is always going to be a fourth of the, not perimeter, but area of ABC, which means 3.5. Don't believe me? Check this out. I know that the area of a triangle is equal to 1/2 times the base times the altitude, 1/2 times B times A. I know that in this triangle, in this situation, I have this smaller triangle, BDE, and the larger triangle, ABC. The area of this small triangle is equal to 1/2 times the base times the altitude. This is the base here, and this is the altitude here. However, I know that the altitude of this larger triangle is twice as large as the altitude of the smaller triangle, because it's, well, that's a midsegment. And I also know that the base of this larger triangle is twice as large as the base of the smaller triangle. You can see that here, and it's a midsegment. That's basically the definition of midsegment. Multiplying these two things together, 2b times 2a, this 2 times 2 gives us 4, which means 1/2 base times altitude, 1/2 base times altitude, but this is 4 times as big, which means this is 1/4 the size. So hopefully you believed me. Anyway, question number 13. It tells us that K is the midpoint of AB and L is the midpoint of BC. It's basically telling us that KL is a midsegment. If it's a midsegment, then it is half the size of its opposite base. In other words, I can take AC and set it equal to twice the length of KL. Solving is just algebra, which gives me -6 is equal to x. It's okay that x is negative. I'm not upset, so neither should you be. For question number 14, it gives us the vertices of a triangle, and then it asks us to find the midpoints of EF and DF, which I do here. Then it asks me to state the coordinates of G and H, which I do here. Then it asks me to prove that GH is equal to 1/2 DE and GH is parallel to DE. It's very, very important. When a coordinate problem asks you for a proof, you must use coordinate formulas like the midpoint formula, the slope formula, and the distance formula. And it is also very important once you're done using these formulas to make some statements. Remember to write the concluding statements or else you'll lose points. While grading Regents exams, I see a lot of students that stop here. They say, oh, this is 3 and this is 3, but they don't say that the two lines are parallel. They say that this is radical 10 and this is 2 radical 10, but they don't mention that that means that one of them is half the size of the other. Very, very important. Let's see. Do I have to say anything else about this? No, it's pretty straightforward. Using the same formulas that we learned about in Unit 1, you should be able to tackle these problems. No big deal. The last thing that you had to do in this packet was do some practice constructions. Hopefully you tried these constructions at home. Pause the video if you haven't done so, and then come back to see if you got them right. I'm looking at question 15. It asks me to construct a median from A to BC. I know that a median is a line that connects a point, vertex of a triangle rather, with the midpoint of the opposite side. So I need to find out where the midpoint is. Well, the easiest way to find a midpoint, the most straightforward construction, is this perpendicular bisector construction. Notice that this perpendicular bisector is a dotted line because it's not the line I'm really looking for. This dotted line is just finding me the midpoint. Once I found that midpoint, I'm able to draw this median in, no big deal. Again, the median connects the vertex with the midpoint of the opposite side. For this question, question 16, it asks us to construct an altitude of triangle ABC. Now, I could have chosen any altitude. I could have drawn a line from B to AC, I could have drawn a line from C to AB, or I could have drawn a line from A to BC as I did here. This line here, notice that it's outside the triangle, but that's okay, because think about what an altitude does. It connects the vertex of a triangle, and it is perpendicular to the base. Doesn't necessarily touch the base. Has to be perpendicular though. So you can see I made this perpendicular construction. In order to do so, I had to draw a dotted line here to extend the line BC in order to get to intersection points. Once I did that, I put my compass here and found intersecting arcs, and then drew a line straight down. This is perpendicular to the base, even though it doesn't actually touch the base, and it comes from the vertex. So it is an altitude. There are two other altitudes that I could have drawn, but I figured I'd show you this because I didn't show you this in class, and it is an interesting construction. All right, for question number 17, it asks us to use a compass and a straight edge to construct a circle that is circumscribed around or about ABC. So let's break this down a little bit. We're looking for a circumcenter. Circumcenter means it is the center of a circle that's drawn around a triangle, and it is constructed by using perpendicular bisectors. So what I did was I made two perpendicular bisectors, and I found that they intersected here. This is the circumcenter, and it's okay that it's outside the triangle because circumcenters are outside the triangle when the triangle is obtuse, like this. Once the circumcenter is made, you can make a circle that hits every vertex by putting the compass on the circumcenter and then extending the compass so that it touches any one of the vertices. It's going to have to touch all three. That's what the construction is designed to do. In this case, it's very big. It might go off of your paper. Don't worry about that. Just draw it to the edges of the paper, and I'll totally understand that you weren't able to add on more paper onto the bottom of your paper. It's not a big deal. All right, for question number 18, it asks us to identify the geometric principle shown from the given list. Each of these diagrams show different geometric principles. Keep in mind that there are 4 diagrams, and there are 1, 2, 3, 4, 5, 6, 7, 8 different principles, so some of them are not going to be used. Pause the video, try this out, and then come back to see if you got them right. All right. For the first one, we can identify the fact that these angles were bisected. This is a construction of an angle bisector. You can see the main arc here and the intersected arcs in the middle, and then that line drawn here, which means that it is an angle bisector. All these angle bisectors intersect at an incenter, and an incenter is the center of an inscribed circle. Remember, inscribed means drawn inside. Inscribed, drawn inside. So that is matching up with angle bisectors, but it's not the center of the circumscribed circle, it's the center of the inscribed circle. Angle bisectors means incenter means inscribed. For number 2, you can see that these are perpendicular bisectors. They're constructed the same way that any perpendicular bisector would be constructed, with arcs on top and bottom. Since they're perpendicular and they're bisectors, that means the point here is a circumcenter. If the point is a circumcenter, that means this circle is a circumscribed circle. Circumscribed means drawn around. Scribed means drawn, and circum means around, whereas in means inside, which means the correct definition is F, perpendicular bisectors. For number 3, we can see that they're perpendicular bisectors here, but they're dotted lines. The real lines here are the medians that connect vertex to midpoint. If it's medians, it's centroid. If this is the centroid, that means it must be choice B. The intersection of the medians is a centroid. And then for number 4, we can see that these are altitude constructions. They're the same altitude construction as the altitude constructions that we've done before, and altitudes meet up at the orthocenter, which means choice D. This is the orthocenter, which is the intersection of altitudes. All right, this video was designed to help with the packet for Unit 6. This is part 2 of a 2-part series. Good luck studying.